All right, we are here on a crisp Monday morning. Finally, back after a little recording hiatus. Don't forget, hit like, hit subscribe, hit the bell. Okay, so we are kind of changing the way that we are doing graphing our exponents or our exponentials. Uh, here's the good thing about today. Today, this is our warm up. This is the only one that you actually have to physically graph. I know some of y'all, you are so excited you can hardly contain yourself, right? I mean, that's has nothing to do with it being a Monday, nothing to do with it being 8:28 in the morning or anything like that. That's just what. All right, so shh. Please use your 2-inch voices beside each other. Okay, now remember, when we plug this in the calculator, we're going to have to use our raise the roof button. Please use your parentheses because it will help with the negatives. Okay, so 2 raise the roof. Now, how do we get that 1 over 4 to go to a decimal? Yeah, the little double arrows right here. Boop. Okay, so 0.25. All right, and then 1/2. Okay, 0.5. All right, anything to the 0 power is 1. Okay, all right. Excuse me. And then 2 to the first should be 2. And then 2 squared, we should know is 4. All right. Y'all got a lot of erasing going on up there. Okay. All right. Now, if we were to graph this, see, this is -2. I want to say this is right here and then right here. And then over 1 up 2. Oop, nope, that's too far. There we go. And over 2, that's 2, 3, 4. Okay, so it should kind of look like this if I could actually hit all the dots. Now, does it have a y-intercept? Okay, yes, it is at y equals 1, or you could say 0, 1. Okay, either way, you know, however that you want to say that. All right, is there an x-intercept? Okay, I hear 2 emphatic no's. Now, here's the worst thing. This little word right here is why some of y'all on previous math tests only got half this credit, or you got this whole thing wrong because you had to actually answer this part right here. What would be your explanation? Okay, that's a good thing. Uh, the student says we didn't. Wait, that shouldn't be an I. We didn't eat. Well, you can tell I was around my country family this weekend. Plot on the x-axis. Okay, so now that's because we now it looked like we were getting close, right? Okay, because we were at -2. All right, well, what if we did this? Okay, just humor an old man. Okay, that's me. I'm the old man. And yes, oh my gosh. Okay, yeah, yeah. That started getting really bad really quick. All right, so do. Wow. All right, so what we're going to do, we're going to actually see. We stopped at -2. Let's see what would happen if we did -3, -4, -5, -6. Let's at least take those out. Okay. So 2 to the -3. Hmm. I get 0, 1, 2, 5. Okay. Okay. I'm getting closer, but I'm not there yet. We've went past Bon Jovi, but we're not there yet. Whoa, we're halfway there. Oh, we're getting closer. Some of y'all are like, well, it has a 0. Just because it has a 0 doesn't mean it's actually right there. And if I could write cleaner, 0.0625. Okay, it has to be at 0, 0. Okay, it cannot have like 0 point anything. All right, just because I think I'm not going to be able to write very well because we all know my handwriting is not great. Let's do this. Ah! That is a good question. The question was, will it actually ever touch it or will it just get infinitely smaller? See, I know the answer. I just wanted y'all to actually think about it a little bit. Because y'all know I have that theory that some people in y'all's grade, if I was to trap them in a human sized brown paper sack, they would just like stop after 30 minutes and just accept the fate that they would just live there. Okay. So, all right. Believe it or not, it doesn't actually touch it at all. It gets really, 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 really close, but it never does. Okay. And this is going to bring us to a new word today. It's very fun to say. And believe it or not, y'all have been doing this a very long time. Okay. You just don't know you have. Oh my gosh. All right. So you need to write this down. Asymptote. Okay. This is an invisible line that a graph gets close to but never touches. Okay? It gets close to it but never touches. And if you're like, you know, the pictures here, and I know somebody has either had this done to them or you have done it to somebody where you have taken your finger and you have went, I'm not touching you, I'm not touching you, I'm not touching you, but you have got infinitely smaller, closer to them, just to bug the snot out of them. Or they have done it to bug the snot out of you. How many of those with siblings? Have y'all had this happen? Mm-hmm. No. Oh, don't tell me that you and your sister are just one of those that always gets along. Yeah. So, but now this is what's funny. Uh, they actually quoted the wrong math thing about this in the show. There's a show that's on used to be on Netflix. It might be on there now. It's on Peacock sometimes. It's called Longmire. It's like an old person show, but I like it because it's like, uh, yeah, it's for old people. But it's based off of a book series where it's this sheriff in uh, Wyoming over a county. He doesn't have a cell phone, and like he'll be with people. They're like their cell phone rings like, "Hey Walt, it's for you." It's really interesting. And his best friend is a Native American. And in the last episode, they're about to have something, and they said, "Remember the asymptote." Instead of remember the Alamo, and they said the asymptote where it, like it will get close but never touch because Walt Weimeyer is a cowboy and Henry Standing Bear is a Native American. They'll get close as they can to each other, but they'll never touch. They'll never actually intertwine. And they're like, "Oh, it's geometry," and there's like, "No, it's not geometry. It's algebra." But okay. Anywho, I couldn't show that picture because it's right before a big gunfight, and no. But it's fairly interesting. Um, all right. So now, this right here, we have this right here. This I'm gonna grab this because I think we need it some more. Where is this? What's this? What's this? We're gonna scroll down some more. Okay. Now, yeah, we have this H and this K thing again. It pops around. Now, when you get to algebra 2, H and K, you'll see these a lot. It happens like it's sprinkled out all throughout the semester. Okay? So, remember, H is the opposite of the value that is written. Okay, this is written as a positive 1, so what's this value? Negative 1. Awesome. Okay, this is negative 4. Okay, now, our H value actually goes here. That is the only value from this information that goes in the chart. Okay, that's the only one. Now, what is the numbers to the left and the right? Well, this would be 0 and 1, negative 2, negative 3. All right, so I've got to make myself a little bit more important here. Woo. All right, now we're plugging this in. Say it again. I can't hear you. All right, so this would be like it is on like the number line for like our graph. Like if our negative 1 is right here, the number to the right would be 0 and then 1, and then our numbers to the left would be like negative 2, negative 3. Like like on your decibel thing for the sound. Okay. So like 2 and then negative 3 plus 1 minus 4. Now, you could actually type that in as is to the calculator. 3 plus 1 minus 4. Okay, so 2 raise the roof, parenthesis, negative 3 plus 1, close it. Now, to get to the next part, you're going to have to scroll over. So the cursor moves down. So the minus 4 is big again. Okay? All right, so we get negative 3.75. So negative 3.75. I probably should make these boxes a little bit bigger. Okay, I did not do a trial run with this the other day on Friday. Okay, so let's try it again. So we have 2 raise the roof, negative 2 plus 1 minus 4. Negative 3.5. Ooh. Okay. 2 negative 1 plus 1 minus 4. And we're sticking with the base of 2 because it's kind of easier that way. Um, for us to, bless you. Bless you again. All right, I'm out of blessings, so I hope you quit sneezing. All right. Sorry. I thought it was funny. All right. Wow, that's crazy. So, our y-intercept, this is when x equals 0. So, what is our y-intercept for this? Yeah, so 0, negative 2, or y equals negative 2. Either one is okay. Okay. Our asymptote, this is when y equals our k value, where our k value is negative 4, so y equals negative 4. This is that invisible. Look, we're learning about an invisible line that a graph will never touch. Here's what's funny. In certain classes, they will ask you to graph an invisible line. You can't tell me that those topics does not kind of prove that somebody was on some type of something when they came up with this stuff. Okay? They had to be on something that could make them smell colors. Okay? And see sounds. Now, here's the good news. Like this example, this is what you're going to have to do on the test. Seems pretty straightforward, right? Yes, you can go to the restroom. Yeah. Well, y'all couldn't hear it on the microphone, but everybody was just cheering. I mean, it was amazing. It was like a sports event in here. I should charge tickets for people to watch. All right. Now, On number A, what is our H value? Our H values here? It's the opposite of what's written. So this is 3. Your screen didn't freeze. I froze because nobody answered. They must have been busy looking on their phones they're not supposed to be looking at. And then they wonder why they don't know stuff. And then I get emails. Well, I wonder why my sweet baby angel has less than an A. Well, your sweet baby angel is looking on Temu and Sheen and Pinterest and Insta stalking their boo thing. Now, all right. So 3 is right here. 1 and 2 and 3 and 4 and 5. So 2, raise the roof. 1 minus 3. Okay. 0.25. Ooh, I got to do a different color. Okay. This one should be 0.5. 1, 2, and 4. All right. Believe it or not, these numbers are like exactly the same thing that we had from our first example, because this is like, because 3 minus 1 or 1 minus 3 is negative 2. Oh, I mean, I could have typed this in the calculator, but I kind of remembered. Yes, no, maybe. Who cares? We're not paying attention. Awesome. All right. So, all right. Do we have a y-intercept? We probably do, but it's not listed, right? So how could we find the y-intercept? Awesome. Yeah. So we would actually plug this in. 0 minus 3. So 2, raise the roof. 0 minus 3. All right. So it would be 0, 0.125, or y equals 0.125. So even if it's not in your chart, you could actually plug in when x equals 0. It's possible. Okay. All right. Now our asymptote, our invisible line, is that when wrong color. When y equals 0. Super duper crazy hard, right? I mean, whew. Some of y'all can tell it was so hard. Y'all got parts of your brain leaking out your ear. At least I hope it's your brain and not earwax, because that's gross. All right. Instead of waiting for a response, I'm just going ahead and say it, because this is negative 2. This is negative 8. Our negative 2 goes here. To raise the roof, negative 4 plus 2. Has anybody kind of seen a pattern yet with the Y values? It's okay if you haven't, but I'm just asking those people that may have started seeing a pattern. My fat fingers hadn't typed in the wrong thing, it'd be all right. But, can't have nothing. What? Oh. All right. There we go. That's more better. All right. Do we have a y-intercept? Yes. This is very easy to find because it's right there. So this is 0, negative 4. Or if you wanted to write it at y equals negative 4. And this is at y equals negative 8. All right. Pretty sure there's a your turn. Right? Got about 4 problems. All right, as they work on your turn, or the people that wait for the 6 people that's going to do the your turn to do it, and then copy down what I'm going to write down on the board. Y'all have time to hit like, hit subscribe, hit the bell. Okay, all that kind of good stuff. Good things. Roll Tide.